Welcome to the next video. I want to show you some more things about type annotations. I have prepared a Python file here, which is called more to type annotations 2.py, and I have some more imports here from the typing module. In this video, I want to show you what the callable abstract base class is, what the mapping base class is, and the optional base class. So union, dict, and list we already had in the last video, so that's not something new. And I have here different functions that I want to go through now. So we have a function here that is called expand list. And in this function, I want to concatenate a list. So if I go into the Python shell for 1 second, if I have a list with the values 1, 2, and 3, and I store it in the variable L, I can multiply my list by 2, for example, and then we would concatenate the list. So we have 2 times the list entries as before. And this is the intention of this function here, for example. And I have here the parameter expander, which would be, for example, this multiplication by 2, for example, and the parameter values, which is a list of integers. And then I return expander times our values list. And hence we return also a list. So the return type of the function is also a list of integers. Then I have a function where I want to just print a list. So the values of the list, so the parameter values is here still a list of integers. And since this function doesn't return anything, I explicitly stated here the return type is none, because as default, if you do not raise any exceptions or something like that, the default return value is none, even though we do not have a return statement here in the function. Okay, then I have a bit tricky function here, which is called expand and print. And here I want to outline what the callable, or what the intention of the abstract base class callable is. Because here I want to pass in 2 functions, one function for the expand function parameter and one function here for the print function parameter, which will be these both functions here. And with the abstract base class callable, you can define what parameters this function should have and what the return type of the function should be. So if I hover over the function here with my mouse, I would see here for the parameter expand function, the allowed parameter list here is for parameter 0 is an integer, and for parameter 1 is a list of integers, and the return type of this expand function here should be a list of integers. Then for the second function, which is here called for the parameter print function, we have exactly 1 parameter, which is here internally called p0, and this should be a list of integers. And the return type of the print function should be none. So here I explicitly stated whenever I pass in a function here as argument for example, the expand function parameter, the function that I pass in as an argument should have exactly 2 parameters and should return here, for example, a list of integers. So I just said, okay, here, for example, this is exactly this parameter list that I have here in the expand list function, for example. So whenever I call this expand and print function here below, and I pass in here an object of the expand list function and an object of the print list function, Mypy would check, okay, does this function that I pass in here have the correct parameter list, and does this function have the correct return type? So whenever you pass in functions to another function, which could be the case sometimes, then you can use this abstract callable class to define the parameter list and the return type, as you can see here. Okay, then I want to show you what the optional type is. Whenever you have a parameter with a default value of none, you can use the abstract type optional to indicate that the parameter has as a default value none. So if I hover over the parameter here with my mouse, I see that I have a union here. So the pipe indicates that it's either or. So we have a union of list of integers or none. So if I type annotate here with optional of list of integers, it just means under the hood it's a union of list of integers and none. And this optional should be used if you have a default value of none. If you have a default value of, for example, 0, you shouldn't use optional. So optional should only be used if your default value is none. Only then. Because as I said, under the hood, this optional of list of ints is equal to union of list of ints, comma, none. Okay. Then one more thing about a function here that I called iterate over dict. If you want to type annotate parameters, that should be a dictionary, it is recommended by Mypy and the typing module to use the abstract mapping class. If you want to type annotate the return type of a function, there you should use the dict abstract base type. It's a bit odd to use here the mapping type and not to use the dict type. It has to do with some underlying problems that Mypy can't resolve right now. Maybe in the future Mypy is smart enough to already or also use here the dict type, but if I type here in dict and I call the function here below, I have a dictionary where my keys are strings and my values are integers, which is allowed here. Since I said here, okay, the keys must be strings and the values can be a union of integers or floats. And the problem here is that Mypy cannot work currently properly with a union of value types for a dictionary. So I said here, union of int and floats, and here, as we can see, the dictionary is okay from the type perspective because the values are integers. But if I hover over with my mouse here, Mypy sees this dictionary as a dictionary of strings, of string keys, and integer values, which is correct for this line. But above here, I said the values are a union of int and floats. So Mypy now thinks, okay, here I have the value type is only int, and above at the function definition, you said the value type is union of int and float. And now Mypy would argue here, okay, it is an incompatible type here because you passed in a dict of string and int, but it is expected to be a dict of string and union of int and float. It's a bit odd, as I said before. So the current proposed way by Mypy and the typing module is here. If you have a union for the types, for example, for the values, for example, or for the keys in a dictionary, to use the abstract mapping type. That is currently the only way that Mypy would see this correct. So now the Mypy warning is disappeared. For all other use cases where you only have one allowed value type for a dictionary, you can use the standard abstract dict class here. That would be no problem. Okay. So that was another video about type annotations. If you have any open points about type annotations, you can write a question in the Q&A section and I can upload a new video if you wish some special kind of topics on this type annotation topic. Okay, then we will see us in the next video. Bye bye.